Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Hasib bin Muhammad Azhaki. Ni lab 4 iaitu magnet dan elektromagnet. Saya grup 13 dan rakan saya Muhammad Hakim bin Hussein dan Faizah binti Mahmud. Saya akan mulakan dengan prosedur dulu. Okey, seperti yang link yang dibagi, inilah link dia. Dan untuk dalam lab ni dia akan ada 3 bahagian, iaitu bar magnet dan elektromagnet untuk DC dan untuk AC. Okey, saya akan mulakan untuk bar magnet. Okey, seperti yang anda dapat lihat, ini ialah south, ini north. Untuk yang south ni dia akan tertarik kepada north, yang north ni dia akan masuk dan keluar, dan kita rasa macam tu lah. Dan yang apa yang anda nampak macam kompas, untuk kompas ni ialah magnetic field. Kita boleh tunjukkan sama ada mana nak nampak atau tak nampak. Okey, dan dekat sini kita boleh nampak bagaimana magnetic field ni lebih kuat ataupun tidak dengan function ni lah. Seperti yang anda dapat lihat, dia semakin hilang dan tak ada langsung. Ialah strength untuk magnetic field dia semakin tinggi, semakin tinggi juga dia punya magnetic field. Okey, yang ni dia ada kompas. Kompas ni untuk menunjukkan dia tertarik kepada apa. Contohnya kalau yang merah ni dan north dia memang tertarik dengan south. Sebab kalau magnet, kalau south dengan south dia akan bertemu, dia tak akan bercantum, dia akan tertarik sama sendiri. North akan tertarik dengan south akan tertarik dengan north. So macam tu lah kita tahu untuk kalau nak guna kompas. Okey, untuk elektromagnet pula bahagian DC. Elektromagnet dia boleh jadi magnet kalau ada current ataupun voltage. Katakanlah kalau dia dah disconnect, dia akan tak ada magnet. So kalau magnet ni dia boleh tarik macam paku ke atau benda-benda yang besi. Kalau elektromagnet ni pun boleh, tapi dengan bantuan yang lebih lah daripada tadi. Okey, apa yang kita dapat tengok sini, ini bateri dan ini positif dan ini negatif. Dan yang biru-biru ni ialah elektron. Elektron akan tertarik kepada yang positif. Lepas tu yang bentuk macam kompas ni, ini ialah magnetic field dan ini ialah kompas. Okey, kalau kita play, kita akan nampak yang elektron ni akan masuk ke bateri bahagian positif. Dan ini loop. Okey, loop ni kita boleh kurangkan dan tinggikan. Kalau tinggikan, dia punya magnetic field dia akan lebih tinggi. Kalau kita kurangkan, kita boleh nampak magnetic field dia semakin berkurang. Okey, yang seterusnya untuk AC. Okey, sebelum tu kita dapat tengok kat sini untuk yang polarity north, untuk polarity south dia akan tertarik kat sini. Lepas tu dia akan buat buat magnetic field. Dia akan keluar lah, kita dapat sini, dapat tengok lingkaran kat sini. Okey, untuk AC ni dia line sikit. Kita dapat tengok kat sini. Sekejap. Dia punya. Okey. Besarkan lagi. Okey. Seperti yang anda dapat lihat sini, dia akan berubah sebab kita dapat tengok dekat sini, dia akan pergi kat positif. Kalau dia pergi kat positif, elektron akan masuk. Tengok ya. Okey, elektron akan masuk ke positif dan positif. Kan kalau dia pergi ke nilai negatif, elektron akan pergi ke bawah, keluar daripada situ. So bermakna yang keluar itu ialah south, betul tak? North. North akan tertarik dengan south. Dan dia akan naik turun dan dia punya polariti dia akan berubah lah, mengikut kepada nilai yang AC ni. Untuk strength dia pun kita boleh tengok sama juga. Kita dapat tengok dia punya nilai elektron dia naik, turun, masuk, keluar. Begitulah juga untuk magnetic field dan tarikan elektromagnet. Dia akan berubah mengikut nilai. Okey, itu sahaja daripada saya. Faiza akan sambung untuk yang seterusnya. Terima kasih.
Assalamualaikum and a good day. Today I'm going to review the questions and answer it. Okay. First, compare and contrast bar magnet and electromagnets. Okay. For this, let's go to the bar magnets first. Okay. What is a bar magnet? A bar magnet is a permanent magnet that can create its own persistent magnetic field. Bar magnet has a permanent magnetic field. It cannot change the magnetic fields of a bar magnet quickly as one. Okay. Bar magnet can use as it, but it does not have a power supply. Okay. For the electromagnet, an electromagnet is a type of temporary magnet that can produce a magnetic field in the presence of an electric current. Electromagnet have a temporary magnetic field can change the magnetic field because it is possible by controlling the electric current that pass through the wire. Electromagnet always need a power supply to create a magnetic field. Okay, that's the contrast and comparison between the bar magnet and electromagnet. Okay, let's go to the second. Identify the characteristic of electromagnets. They are variable and what effect each variable has on the magnetic field strength and directions. Okay, characteristic of electromagnet and effect on the magnetic field strength and direction. Okay, the characteristic is first for power strength. The strength of electromagnet that result from combining a magnet with an electrical field from a power source is determined by both the strength of the electrical current a power source runs around the magnet and the existing strength of the magnetic field, whereas the strength of the base magnetic field from the magnet is a static property of the magnet itself. Someone tinkering with the electromagnet can increase or decrease the strength of the induced magnetic field by increasing or decreasing the strength of the current from the power source. Okay, the direction also go to uh, from the power source. Okay, second, for the polarity, the scientific term for the charged magnet or any particle for the matter carries is called by the magnet polarity. A positively charged magnet has a positive polarity and negatively charged magnet has a negative polarity. The properties of induction dictate that the polarity of an induced magnetic field will share the polarity of the magnetic field whose interaction with an electrical field generates the induction in the first place. Consequently, decreasing the electromagnet will magnify the strength of the magnet. Base polarity, not change the polarity. Okay. And the third, magnetic plus power. An electromagnet works by using a source of the power to introduce an electrical field into the existing magnetic field, which a magnet actually produces. By introducing this additional electric field to the existing magnetic field, the electrical field induces an additional magnetic field to the area around the magnet. These two magnetic fields combine that effectively increase the strength of the magnet to attract a positively charged magnetic force to it, or repel magnets and charge of the same charge. Okay, relate magnetic field strength to the two distance. Okay, so the answer is the total number of flux lines depends on the strength of the light source and constant with the increasing distance. where a greater density of a flux lines, which is a line per unit area, means a stronger energy field. The field of intensity inversely proportional to the square of the distance from the source, or the magnetic field from a wire decreases it with distance from the wire. Instead of the field being proportional to the inverse square of a distance, as the electric field from a point charge, the magnetic field is inversely proportional to the distance from the wire. Okay, that's all for a question for a lab 4. Thank you. Okay, so next question is explain how you can use a battery and wire to make a magnet. Can you make it a stronger magnet? Can you make the magnet field reverse? Okay, so the answer is when you connect the wire to the battery, electrons begin to flow in the same direction through the wire, and it will generate a magnetic field around the wire. By cooling the wire around a stainless steel core, creating a combined magnetic field in the wire and core which was strong enough to pick up objects. Electromagnets are useful because their magnetic field can easily be controlled. The greater the current, the stronger the magnetic field. Increasing the number of the coil also increases the magnetic field. The strength of an electromagnet depends on electrical current, which flow through it by its wire. Okay, but not on that, what derives that current? Of course, can make a stronger electromagnet by adding the batteries, but the strategy you would use depends on the relative resistance of the two components that being used. Yes, it can make the magnetic field reverse, but it not efficient to do it. Okay, so based on your observation, explain how does the electromagnet work. Electromagnet is different from the permanent magnet. So, electromagnet is made of a coil of wire with electricity passing through them. By moving the charge, create magnetic field. So, when the coils or wire with an electromagnet have an electric current passing through them, the coils behave like magnet. When the electricity stops flowing, the coil does not act like a magnet anymore. Electromagnet used in a lot of electronic device when the magnetic force are only needed for a short period of time. Okay, this is how the electromagnet work. Okay, okay, that's all for the lab for questions. Okay, thank you.
Okay, Bismillahirrahmanirrahim. So, saya Muhammad Hakim Ibn Husin. So, hari ini saya akan terangkan untuk next session iaitu the Ampere's Law dengan Biot-Savart Law. Okay, untuk first, untuk Ampere's Law, kita menggunakan formula ini. Okay, formula ini valid only when the flux of electric field through the loop is contained in time. Otherwise, its rate of change of displacement current has been added to the normal current on the right hand side. Okay, so mengikut apa yang saya research, so ini ialah Ampere's law. Okay, in the electric case, the relation of field to source is quantified in Gauss law, which is very powerful tools for calculating electric field. Okay, so ini adalah Ampere's law application. Dia ada magnetic field inside. Okay, ini adalah detail-detail untuk Ampere's law. Okay, untuk seterusnya ialah Biot-Savart's law. Okay, Biot-Savart's law didatangi dengan formula ini. Okay, originally formulated for static simulation as well, is more general for it is valid even the electric flux change in time provided the electric field is given by gradient potential. This happens, for example, when capacitor connected to battery with negligible self-inductance get charged, a magnetic field around the capacitor does not obey Ampere's law, but is given by the above Biot-Savart formula. Okay, so untuk detail dia, macam ni, okay, dia menggunakan formula ni, okay, formula ni dah sama je lah. Okay, so untuk field contribution of current element dia, okay, the relationship between magnetic field contribution and its source current element is called Biot-Savart's law, okay. So the direction of magnetic field contribution follow the right-hand rules illustrated for straight wire. This direction arises from the vector produce nature of dependent upon electric current. Okay, so next kawan saya akan terangkan iaitu Muhammad Haziq bin Muhammad Zaki.
Untuk conclusion pula, as a conclusion, my teammates and I get to discover the magnetic field strength. After that, we also get to identify the characteristic of an electromagnet that were variable and what effects each variable has on the magnetic field strength and the direction. Hence, we get to explore the electromagnetic interaction, the compass and the bar magnet. We get to compare the magnet with the electromagnet with the magnet. After that, we also get to identify the characteristic of an electromagnet that were variable and what effects which variable has on the magnetic field strength and the direction. That's all from us. Thank you.